What happens when two elements form more than one compound? Can their combining ratios be completely random? Or is there a hidden pattern? Well, chemistry has the answer. And that answer is the law of multiple proportions. It tells us this: when the same two elements form different compounds, the masses of one element that combine with the fixed mass of the other are in simple whole number ratios. Intrigued? Let's dive into how nature keeps its math clean, even when the combinations vary. Let's look at a simple example straight from textbook. Hydrogen combines with oxygen to form two different compounds, 1 water H2O, where 2 grams of hydrogen plus 16 grams of oxygen equals to 18 grams total. 2 hydrogen peroxide H2O2, where 2 grams of hydrogen plus 32 grams of oxygen equals to 34 grams total. Now look closely. With the same 2 grams of hydrogen, oxygen is combining into different masses, 16 grams and 32 grams. Let's find the ratio 16 is to 32 as 1 is to 2. A simple whole number ratio. And that's the law of multiple proportions in action, showing us that even when compounds vary, the math of matter stays beautifully consistent. Let's turn atoms into Lego bricks. Imagine hydrogen atoms as red bricks and oxygen atoms as blue bricks. To build water, you use 2 red plus 1 blue. To build hydrogen peroxide H2O2, you use 2 red plus 2 blue. The red bricks stay the same, but the blue bricks follow a simple whole number pattern, 1 and 2. Just like Legos, atoms combine in countable, predictable ways. That's the law of multiple proportions made visible. Here's a classic example to bring the law to life. Let's compare carbon monoxide CO and carbon dioxide CO2. In CO, you have 12 grams of carbon plus 16 grams of oxygen. In CO2, it's 12 grams of carbon plus 32 grams of oxygen. Now notice, carbon stays constant at 12 grams. But the oxygen changes from 16 and 1932. That gives us a simple ratio, 16 is to 32 as 1 is to 2. Even though both compounds are made of carbon and oxygen, they're entirely different substances because the elements combine in simple whole number ratios. That's the law of multiple proportions, perfectly illustrated. Atoms are indivisible units, so they can only combine in whole numbers, 1 atom, 2 atoms, and so on. You can't have half an oxygen atom in a stable molecule. That's why the combining mass ratios also turn out to be whole numbers. Let's clear up a common confusion. The law of definite proportions applies to one compound. It tells us the elements combine in a fixed ratio by mass within that compound. The law of multiple proportions applies when you have 2 or more compounds made from the same elements. It compares the ratios of one element when the other is held constant. So, one compound, fixed ratio. Multiple compounds, whole number pattern. Let's wrap this up. When the same 2 elements form different compounds, the mass of one element varies in simple whole number ratios. This is the law of multiple proportions. It's proof that nature follows order, not chaos. And this law was a game changer. It helped John Dalton shape his atomic theory, laying the foundation for modern chemistry. Up next, we move from mass ratios to volume ratios with Gay-Lussac's law of gaseous volumes. Get ready to explore how gases combine with surprising simplicity.